Yes, today's unit is again wave optics, and the smaller part of wave optics I have taken diffraction, higher secondary second year physics, and I will just give you a little idea regarding diffractions, and followed by this class I will discuss a NEET IIT given three definition of the diffraction. And you may ask why I have given these three definitions, because a lot of statement type of questions and true and false and very often appears or asked in the exam. That's why I have given this. We must have knowledge on this one. Informative questions are also being asked from this one. So the phenomenon of bending of light around the sharp edge of the obstacle or aperture of comparable wavelength is called diffraction. I will explain. Means uh, I will give you the definition, the figures, and along with this figure, I will explain the phenomenon. First of all, you minutely follow that if your aperture is of this type, the sharp is, and the light is made to pass in this way. Width of the aperture or the slit, say it is a, and that should be comparable wavelength lambda of the wavelength, more or less same, or aperture is a bit larger than wavelength of the light pass through the aperture. So later on I'll explain. So more or less same, lambda almost comparable wavelengths or slightly better than this one, then this diffraction phenomenon occurs. Question asked what is the condition that diffraction occurs. So you may write a approximately equal to lambda of the wavelength, then the phenomenon of diffraction occurs. Number two, the phenomenon resulting from the superposition of wavelets from secondary waves originated from the wavefront. This is wavefront. From each of the wavefront, each from the point, locus point, that generates secondary wavelets. So the wavelets generating from the same wavefront, from the different part, that superpose over other. Am I right? And due to this superposition, the diffraction phenomenon occurs. Another is diffraction is nothing but penetration of light into the region of geometrical shadow. In the shadow, you will get some amount of light is there, and this phenomenon of penetration of lights inside the shadow is called, into the region of geometrical shadow, is called diffraction. This is in short information on this Fresnel diffraction, and another is Fraunhofer diffraction. Again, in short, I am telling, in Fresnel diffraction, your only two condition is required in Fresnel diffraction. First one is here your slit, the edge of slit should be straight, not sharp, not pointed, straight. First condition, the edge is straight. Example, small wire. In case of small wire also this diffraction occurs. And another is small opaque disc. If the light is fall upon this one, again Fresnel diffraction occurs. And the screen, both are fixed. Light is coming out from this source, and in this way it is diffracting, and it is focused on the screen. The distance between the source and the screen, either both are fixed, or either source is fixed or screen is fixed, or both source and screen is fixed. If these two conditions occurred, then Fresnel diffraction is possible. So here this in Fraunhofer diffraction, what's happened? It is diffraction at single slit, means one slit through one slit deflection. Fraunhofer diffraction occurs, and number two, diffraction at double slit, also an example of Fraunhofer diffraction. And the condition is that both the source and the screen, source of the light emerging out from where it is called source and the screen upon which it is focused, where diffraction fringes are produced on the screen, their distances are at infinite distance. This is the main point. You should keep it in mind. Fraunhofer. And third part of today's class is single slit diffraction. And this is the theory part of today's class. And in more elaborate way, let me explain. So the mechanism of the diffraction, say this is wave, the source of the wave is coming out from here, and the wave, this type of waves here, the wave of length, the one part of the wavelength is here lambda, and lambda has a comparable side of slits with say here a. So here slits with a maybe are more or less same or a bit, a is greater than lambda. This is the condition where diffraction occurs. What happens when it is start to pass through this one? So after passing from the slit width, after passing through the slit or the aperture, it's spread in this way. So in this way it disperses, propagates in this way. So here we get one is in the central position at O, it is called central maxima, and here at the extreme at that point, and this point, that point, and this point, this is first minima and this is first second minima. That minima here it is destructive interference, means here the fringe, here dark fringe will occur, again here dark fringe occur. So this is first minima and it is second minima. So one interesting thing is that here the intensity of first minima and second minima is different. So also the fringe width, if you consider the fringe width, so fringe width is different. That is from first minima and second minima, that is from the center one dark point, another dark point, that is first minima and second minima, the fringe width is different and also intensity is also different. Intensity is also different and also fringe width is also different. And if you consider in lower part for clearance, for clarity, I have shown, means if it is minima, that is maxima, that is maxima. I have shown maxima here on the both side, minima maxima is the same. So it is first maxima and it is second maxima. Again the intensity of first maxima and intensity of second maxima is again different, and the width of first maxima and second maxima is also different. So this is simple representation of the diffraction of light when it passed through the slit, and the condition here I have mentioned. First condition is with the state, sorry, as is state, the slit, this is slit, am I right? Theta, Fresnel diffraction. In Fresnel diffraction, we have seen it is source and it is slit, and this is the distance of slit and source d. So the condition is that the slit as is that source and the screens are at definite distance apart, fixed distance apart. So this is Fresnel diffraction. Here, simple. In case of Fraunhofer, you mind that it is a single slit diffraction. I will again take single slit diffraction in a separate manner. So here, the source of light is here and the screen is here, but here both source of light and screens are at infinite distance. Since the source is at infinite distance, so light falling on the screen is parallel. Am I right? The source at infinite distance always emits light parallel. So the parallel lights I have assumed here is now going to fall upon the screen. Since the screen is also at infinite distance, so actually these lights are make convergent to a fixed point by placing a convex lens at appropriate distances. And this convex lens, after this, before the screen, that is screen is necessarily placed at focal length or focal plane of the convex lens. This is the condition. Then these parallel lights converge to a specific point. This phenomenon is actually is called Fraunhofer's diffractions, where source and screens are at infinite distance and the light parallel lights coming from the source at infinity is made to fall upon the screen after passing through the convex lens, where the screen is placed on the focal plane of the convex plane. This is Fraunhofer diffraction. So single slit diffraction, it is given in your course and very often questions asked in this, and it is a very important part. Very often in entrance exam question is asked from single slit diffraction, means it is a type of Fraunhofer diffraction. Now what's happened in this diffraction, we will it is a striking point, and from where each and every time question asked in the entrance exam, NEET exam, JEE, IIT, and lots of exams which I have mentioned, and at the very beginning the question asked from this one. I am going to solve these problems from this point of part of view. So here we have assumed plain wave front, plain wave front, and this is a slit where state as, or the as is state, and here it is a Fraunhofer, a lens will be there. So this is a lens. Am I right? So this is a lens. So when the light from this source passed, am I right? So when these two lights these two lights come and meet at point after passing through the lens, when lens is placed at the focal plane at center O, this is I maximum, that is bright lines appears here. Now, so when this on diffraction, due to diffraction, touches the corner of the at the final edge of the lens, so they diffracted in this way, they comes in this way, go in this way, and here first, and this is another theta 2 and another theta 3. Am I right? So here theta is equal to actually angular width. Am I right? So that theta 1, 2, 3 develops. So here this is the point. So in this way we will get the point P, and this is assumed here as the first dark point, and that in this way a bright point and dark point, bright point, and that first dark point is called first minima or secondary minima. First secondary minima. So first minima. So at this first minima, if you draw a line from this point to this, then the difference of path difference will be described by these two is equal to path difference, is a rectangular one, uh, uh, delta, capital delta, path difference. Now if path difference is 0, then it will come, this line will be that straight, and that straight line will be equal to the a, and that a is nothing but width of the slit. So if it is width of the slit, so what's happen, path difference is 0, means the line will pass straight to this one, that is phase is equal to 0. So if phase is equal to 0, that central point is the maxima, bright. So this is bright, am I right? So for first minima, we know I have not derived a into sine theta, and when lambda becomes 0, means path difference becomes 0, then that becomes equal to, that path difference become equal to a width of the slit, and that width of the slit is exactly equal to the lambda of the plane wave front, that is, that will become lambda, that is lambda is equal to a sine omega t, a sine, and this is very important. It is the formula of the first secondary minimum. Very often we will apply the formula lambda is equal, actually n lambda is equal to a sine theta, where n is equal to 1 2 3 4 5 6. So if it is first, then in place of n we will put 1. If it is second minima, 2. Since we have written first minima, so in place of n, this will be lambda is equal to a sine theta. So and another is from the center, if you try to find out the distance, nth distance, at what distance first, second, third, fourth, maxima or minima, that distance is equal to xn. So that xn is equal to n lambda d by a. Mind that it is again important, it is for first minima, distance from the center, nth means first, second, third, fourth minima is given by n lambda by n lambda d by d, where n is equal to 1 2 3 4. Lambda is the wavelength of the light, the source used, and d is the distance of the slit between slits and the screen, and a is the width of the slit, that is the a and b, in between the distance is a. This is this. Now first maxima, that is after minima you will get intensity, you will get bright line, am I right? So you are getting first minima, then first maxima, then second minima, then second maxima. So what is second maxima? Again, path difference I have not derived is equal to a sine theta. For this, we have in place of a sine theta, we have placed here lambda, n lambda, am I right? So for first maxima, n lambda will be twice n plus 1 lambda divided by 2. So twice n plus 1 lambda divided by 2. So n is equal to 1 to 3. So first bright line will get n is equal to 1 equal to thrice lambda by 2, second 4 5 lambda by 2, third 7 lambda by 2. In this way, if it is first minima, then simple n lambda d by a, lambda is equal to a sine theta, and the distance from the center is xn is equal to n lambda by d. And for first maxima, lambda is equal to, it is not n lambda, it is twice n plus lambda by 2 is equal to a sine theta, and distance from the center of the first, second, third, fourth maxima is equal to twice n by n lambda. Here you got n lambda d by a. So in place of n you put twice n plus 1 lambda by 2. 2 means 2, a is a. So this place 1 is only n lambda, here in place of first we have put n is equal to 1, and since it is first maxima, it is twice n plus 1 lambda by 2, and its distance from the center of the first, second, third, fourth maxima is twice n plus 1 lambda divided by twice a, where a again is equal to distance between a and b, means width of the slit. And this is very important, you keep it in your mind. So here we have assumed the source here, from this source the diffracted light is in this way. So we have got it is first minima, second minima, first minima, second minima, and first maximum, second maximum, first maximum, second maximum, and this is central maximum. Now it is separated. The distance between these two is x, and this is x, and this is theta, and this is theta, where theta is equal to width of angular width of fringe, angular width, and x is equal to linear width, linear. So you have got central maxima intensity is highest, it is bright point, and these are the dark point, dark point. This is bright point, bright, dark, 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 dark. This is bright, bright, and this is in the central position, central maxima. Here the angular width, here theta plus theta means twice theta. If you assume twice theta is equal to lambda by a, lambda is the wavelength of the light used from the source, and linear width means here x and x, total linear width is equal to twice x, linear width twice x, that is equal to twice d into theta, twice into distance between the slit and the screen is d, and theta, here theta in place of d we have placed f, means the screen is placed at the focal plane. So distance d is nothing but focal length of the lens, and f is theta is of this. Again from above theta is equal to lambda by a, we have placed here twice f into lambda by a. So linear width is equal to twice twice f lambda by a. So from this point a lots of question on when we'll solve the entrance question, we'll find that angular width theta is inversely proportional to the width of the slit, and linear width, in case of linear width the is again also inversely proportional to the slits, width of the slits. More the width, less is the angular width, and more is the less is the width of the slit, more is the linear width of the fringe. So this is all about the theoretical part. Very often the point this, the distance from the center, first minima, that is not first minima, nth distance of the minima is equal to n lambda d by d, and nth distance of this equal to of first nth minima maxima twice n plus 1 lambda by twice a is very very important. So this is all about of the today's theoretical part of today's class, and a lots of questions answer is ready. I am going to solve in the next class, and all of the entrance competitive exams and probability questions are to be which are supposed to be set up in the entrance exam will be discussed in the next class. Thanks a lot for watching the class. Don't forget to subscribe the class and let others to get the information on web optics in physics.